Hi learners, welcome to Virtual Chemistry. This is Dr. Padmaja. Please subscribe to my channel for more videos and updates. Now let's continue our topic. Today I'm going to discuss about the third symmetry element, that is inversion center. And inversion center is indicated with the symbol I. And let me explain few points before going in detail. I will explain in detail with an example. So here let's see what is a symmetry element. I told you in the beginning of this topic, introduction to symmetry. Symmetry element may be a point or a line or a plane. So in this case, if you see, so it is a point. Symmetry element here is a point, and generally this point will be center of gravity. For any molecule, if you take, there will be center of gravity. And it has to be, the molecule has to be inverted through center of gravity. And after doing this operation, if the molecule gives identical or equivalent structure, then we can say that molecule is possessing inversion center. And the second point is, let's see what is the symmetry operation here. Symmetry operation is always here we used to do inversion. So we used to invert the molecule. So for example, there is a molecule where it has center of gravity. Then what you have to do is, you have to look for the three axes that are existing in a molecule. Let's say X, Y, and Z axis. So plus Z minus Z, plus Y minus Y, plus X minus X. So then when you invert the molecule, plus Y will be occupying to minus Y. So plus Y will replace with minus Y, plus X will replace with minus X, and plus Z will replace with minus Z. So these things have to be done in order to have a molecule, to have a center of inversion center. Then only it is possible. And moreover, if you do it twice, the molecule becomes identical. So if you do twice, 2 times of inversion, then the molecule will be giving identity element. Now let me explain with this two examples. So first example I'm going to take here is hexafluorosulfur, SF6 molecule. And the shape of the molecule is octahedral. Here you have 4 equatorial fluorine atoms and 2 axial fluorine atoms. And if you see the 3 axes here, first please draw the axis so we can find how can we invert this molecule. So these are the 3 axes. And let's give numbering to the atoms as well. 1, 2, 3, 4, 5, and 6. See here, this is all positive axis. These are all negative axis. That means what? F5 can be replaced with F6. And where is the center of gravity here? This exactly on the sulfur. So when you invert the molecule, you have to invert 2 with 4, 3 with 1, and 5 with 6. Now let's do the operation. So here it is, inversion through center of gravity. To center of gravity. Then what happens? What molecule we are going to get? Now we can see here it will come F6 and this is F5. And on this axis this becomes F4 and it becomes F2. On this axis it becomes F1 and it becomes F2. Now if you see the structure is octahedral, there is no change in the structure. and the atoms also occupying the same positions for equatorial and to axial. So it is almost looking like the same, but it is not identical. So it is equivalent structure. So it is having center of symmetry. I told you whether it gives a equivalent or identical, it will give you, it will be having that particular symmetry element. So when this molecule is inverted through the center of gravity, that means here we did inversion in this way, here we did inversion in this way, on this axis we did inversion in this way. All are inverted through the center of gravity. After doing that operation, we got the structure, and if you observe the structure, almost it is looking like the same structure that is there in the beginning. That's why we say it is an equivalent structure, and it is having identity element in it. Sorry, inversion element in it. And this is the first time we did. And one more time, if you did, the same thing will happen. We'll get F1, F5 to this place and F6 to this place, and here also, here also. So that will be nothing but this structure. That means we are going to get identical structure after doing this. So that's the reason why. Let me draw that structure also. After doing this operation, what we are going to get here, sulfur will be in the middle, and there are 4 ligands in equatorial position and 2 ligands in axial position. First draw the structure and later give the name. Now you see initially before this operation F5 is here. Now it becomes F6 and here it is F5. Now this F2 and this is F4. Now here it is F1, it is F3. Now you see these two are same. These two are same. That is the reason why they are said to be identical. So how many times after doing inversion center we got identical structure? 2 times. That's the reason why I power 2 is equal to E. Or what we can say, 2 times means multiplication is equal to. So this is the simple formula that we can understand easily. Let me explain one more example. That is second example. I'm going to take ethane, staggered ethane. Staggered ethane, and I'm going to take Newman projection formula to explain this. So actually here carbon will be at the center of the circle, and the carbon we are not showing here. These are the 3 hydrogens in the front side carbon, and the back side carbon will be having 3 more hydrogens. These are the 3 more hydrogens in the back side carbon. That means it used to have a structure like this. Okay, this is Newman projection formula. Now let's see whether it is having center of symmetry or not. So exactly if you see, the center of gravity will be here. The center of gravity will be on carbon-carbon bond. Now through that bond, if you see, we can draw 3 axes. So this is one axis. Let me draw a different color. This is one axis passing through these 2 hydrogens and passing through these 2 hydrogens and passing through these 2 hydrogens. You say this is plus and these are minus. Always the molecules with which are having atoms on plus and minus axis only will be having inversion center. If you observe this molecule, it is having hydrogen on plus Z, minus plus 6, minus plus 5, minus 5. Now let us invert through center of gravity. Invert this molecule through center of gravity. Then what happens? You see. Now with the backside hydrogen, see, this will occupy this position. Let's give the numbering 1, 2, 3, A, B, C. Now see, H1 will be replaced with HB, and H2 will be replaced with HC, and H3 is replaced with HA. Now let's try it. front hydrogens now becomes these hydrogens. It is inverted through the center. So it becomes now these will come on the top. This is H3 and this is H1 and this is H2. Now the backside carbons are, backside hydrogens are, these will go and occupy the backside. So now here it will be HB and it is HC and this is H. If you see this, it looks the same. The only thing is the position of hydrogens has been changed. So that's why we say it is equivalent geometry. Equivalent. So inversion center is present. Now when you do one more time, let's do one more time and let's see what happens. The same thing, inversion center, one more time we are doing now. So it will give you, now just invert through center of symmetry, center of gravity. Then the front side hydrogens. Here you see H3, HA. So HA will come here and H3 will go here. Next, here H2 and HC. So H2 will go here and HC will come to this place. And here it is HB and H1. So here it comes H1, here it comes HB. You just compare these two geometries, they are same. So that's why it is said to be identical. It is said to be identical. So whenever we got either equivalent or identical geometry, then only we say that these molecules are having that particular symmetry element. Now, what symmetry element we did here? We did inversion, or inversion we did through center of symmetry, center of gravity. That's the reason why this is also one of the example where the molecule is having center of inversion. Those molecules which are having center of symmetry, inversion center or center of symmetry, the other names for this are said to be centrosymmetry. They are said to be centro. The other name for this inversion center is center of inversion or inversion center. So in this way, if you find, first of all, no need to go directly and invert the molecule. First, you observe that whether it is having center of gravity, and through that center of gravity, is it having plus x, y, z to minus x, minus y, minus z. There should be symmetrical arrangement of atoms. Then only those molecules are having center of inversion. So if you observe these 2 points, then you can easily understand which molecules are having center of symmetry and which are not having center of symmetry. I will explain one more example where they don't have center of symmetry. Example, third one, I'm going to take water. In this water, if you see, I told you first find where is center of gravity, and the center of gravity in this molecule is here. And if you draw 3 axes through this, is there any symmetrical element on x, y, z? No. And in that case, we can say simply there is no inversion center is absent. No I. How can we prove that? Let's see. Let us invert this molecule. Let's see what happens. If you do inversion to this center of gravity, you are going to get this structure. Are they both same? No, these are not same. They are not same. That's the reason why water is not having center of symmetry in it. In this way, if you observe only these 2 points, you can easily identify which are having center of symmetry, which are not having center of symmetry. Hope you understood this topic. Thank you for watching. Please subscribe to my channel for more videos. Thank you.